Lesson 9-2 is logarithms and logarithmic functions. So the first thing I'd like you to do, you can do this on your own time, is read page 509. Page 509 basically describes how a logarithmic function is really just the inverse of an exponential function. So if we think about inverses, what happens is the x and the y values are swapped. When you're trying to find an inverse function, no matter what your function is, you swap x and y. So if we consider the exponential equation y equals b to the x power, when you want to find the inverse, you would swap x and y, x equals b to the y power. Now when you try to resolve this for y, we call it the logarithm of x. And so instead of saying x equals b to the power of y, we can write it as y equals the log base b of x, and that's exactly how you want to read it. And these two functions now are inverses. Okay? The problem here is you don't want to write it as x equals b to the power of y, because in exponential form here, you don't have it solved for y. And it's impossible to solve it for y. And so we just define it as y equals the log base b of x. It's the inverse of b to the power of x. Okay, so we can go from exponential form into logarithmic form pretty easily. This is what we would call exponential form. B to the power of y equals x. The same thing can be said using a log. The log base b of x equals y. One thing that I want to point out here is that in exponential form or in logarithmic form, b is your base. Here, b is the base of the exponential equation, and over here, b is the base of the log. Okay, the log base b of x equals y. The logarithm is really defined as the power that you're using in your exponential equation. Let's try converting back and forth here. So we've got some equations written in log form, and we want to rewrite them in exponential form. So what you want to do is start with your base. Our base here is 8. So the base is 8. My power is on the other side of the equal sign. It's 8 to the 0 power equals 1. These mean the same thing, saying 8 to the 0 power equals 1, or saying that the log base 8 of 1 equals 0. We're really saying the same thing. So these are equivalent, but just two different ways to write your equation. I like to think of converting logarithmic form into exponential form as kind of going in a circle here. You start with your base, your little number. Your power is on the other side. 8 to the 0 power equals 1. And that's a good way to kind of remember how to set these up. Also, whatever you write for your equation should make sense. 8 to the 0 power equals 1, yes, that's true. If you had your numbers mixed up, like if you had 8 to the first power equals 0, well, you know that's not right, because it doesn't make any sense. So whatever equation you write needs to be something that's a true statement. In letter B, we've got the log base 2 of 1/16 equals -4. So this little 2 here represents your base in your exponential equation. So it's base 2 to the power of -4 equals 1/16. Now ask yourself, does that make sense? 2 to the -4th power equals 1/16. Yes, it certainly does, because you can rewrite this negative exponent as 1 over 2 to the 4th, and that gives you 1 over 16. Okay, I know there's one more example on this page. I'm going to have you try letter C on your own. Change it from log form into exponential form. Moving on to to example 2, we're starting in exponential form, and we want to rewrite the equation in logarithmic form. So you have to consider your base here. We've got a base of 10. 10 to the 3rd power equals 1,000. Well, we could say that the log base 10, 10's your base here, of 1,000 equals 3. Your log is always going to be equal to the power. So it's log base 10 of 1,000 equals 3. In letter B, we've got a base of 9. 9 to the 1/2 equals 3. It's log base 9 of 3 equals 1/2. 9 to the 1/2 power equals 3. Here's how you want to set it up in log form. Log base 9 of 3 equals 1/2. Again, your log is always equal to the power. Okay, again, I want you to try letter C on your own. It's in exponential form. Please convert it into log form. Now, knowing how to convert back and forth between log form and exponential form is going to be very handy when it comes to evaluating expressions or solving equations kind of down the line here. So it's important that we know how to convert back and forth from log to exponential. So here's a good example of that. We want to evaluate log base 2 of 64. Now what we know here is that this log is equal to some power. So I'm just going to set it equal to a letter. I'm going to pick W. Log base 2 of 64 equals W. Well, if I set up an equation here, what I'm really saying is that 2 to some power has to equal 64. That's the definition of log. 2 to some power, W, has to equal 64. Now 2 to what power equals 64? I think it's 2 to the 6th power, so I know that W equals 6, or this log is equal to 6. Log base 2 of 64 equals 6. In part B, we've got log base 3 of 81. What does that equal? Well, 3 to what power gives you 81? This is where your power sheet will also come in handy. 3 to what power gives us 81? Well, 3 to the 4th power is 81, so this log is 4. Okay, so a logarithmic function, this basically describes the graph. I'm not going to show you any graphs on here today, but a log function is a function involving a logarithm. So here's an example, y equals log base b of x. B can be any number, x could be any number, but b, it has to be greater than 0, and b cannot equal 1. Same rules applied when we were graphing exponential functions. So these are just some restrictions on your b values. Now here's some facts about the graph. Think about the facts that we had about exponential functions. Because this is the inverse to those exponential functions, domain and range swaps because the x and the y values have swapped. So the domain is all positive reals from 0 to infinity, not including 0. The range now is all reals. The y-axis has become an asymptote, and the graph contains the point 1, 0. That means that 1 is the x-intercept. We'll practice graphing some more of those later. Okay, so let's move on to the last part here, which is solving logarithmic equations. This time we're not missing the power, we're not missing the number on the right side here, but we're missing what we're taking the log of. So it's the log base 4 of n equals 5 halves, and we need to figure out what n is. So 4 is your base, 5 halves is your power, and it should equal n. So if we convert this into exponential form, we can figure out what n is. 4 to the 5 halves power equals n. Well, this is a really easy calculation. On your calculator, you'll type in 4, hit the power key, then use parentheses to the 5 halves power, and we get 32. So n equals 32. The equation is solved. Here's the last one. We want to figure out what x is. So my base is 9. The power is 3 halves. And that should equal x if we convert it into exponential form. So 9 to the 3 halves power. Again, on your calculator, if you calculate this, 9 to the 3 halves power is 27. Okay, so the biggest thing that we learned today, or the biggest thing that you need to know moving forward, is how to convert back and forth from a log into exponential form. And those are some of the tricks that we're going to be using later on in the chapter when we get to solving equations.